Hello, I Anand Jain welcomes you to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in engineering education. Today in our playlist Induction Motor, we will study speed control of induction motor by variable frequency drive, and we will learn all sections of block diagram of variable frequency drive, and we will understand working as well as technical limitation and other precautions required to operate and use variable frequency drive. Let's start. This squirrel cage 3-phase induction motor is the most rugged, economic and almost maintenance-free industrial electric motor. Its operation is very convenient and its performance is also very good. But when operated from a constant frequency main power supply, that's 50 Hz, such AC induction motor are almost fixed speed motors, and their inherent speed regulation from no load to full load is just 5% of their synchronous speed. So most of the time such motors are used for constant speed operations, but we may also need variation in motor speed as per load demand, and to match right speed of electric motor with load we need variation in motor speed. An electronic variable frequency drive can provide us continuous, smooth, flexible variable frequency supply for a motor to operate 3-phase squirrel cage motor at variable speed conditions as per load demand. Development in modern power electronic switching devices such as IGBTs, improved design and development of converter circuits, and development in the field of microcontroller and feedback tools have increased widespread use and popularity of these variable speed drives for variable speed operation of electric motors. And all that improvement not only increased their performance, reliability and efficiency of variable frequency drives, also reduced the cost of these modern electronic variable frequency drive supplies, and that have increased the use of this low cost and very rugged squirrel cage induction motor in the field of variable speed load applications. And modern VFD control speed of these squirrel cage induction motor by varying the frequency of power supply given to the stator of these motors, and during operation modern VFD can also regulate the magnitude of voltage as well as frequency supplied to motor, and that can control motor torque and other operating parameter of this squirrel cage induction motor. We know in this squirrel cage induction motor a 3-phase space displaced balanced winding is wound in stator core, and when that winding wound for P number of pole is given F supply frequency, it produces a rotating magnetic field of synchronous speed ns rpm given as 120 F over P, and as per electromagnetic induction, rotor have induced current, and that current interact with rotating magnetic field and rotate rotor in the direction of rotating magnetic field with a certain speed difference with respect to rotating field, and motor speed is given as ns1 minus s, where s is known as slip or percentage difference of field and rotor speed per unit of synchronous speed, and that depends upon mechanical load torque connected on motor shaft. Now the torque developed by electric motor depends upon its rotor current and the magnitude of working air gap flux between stator and rotor, and this flux can be controlled by control of applied voltage magnitude, and VFD can control both rotating speed by controlling synchronous speed by varying applied frequency, and it can also control torque produced by motor by controlling applied voltage which control air gap flux magnitude. In a stator winding of P number of pole, when supply frequency is F, the synchronous speed of rotating magnetic field is 120 F over P got a certain value, and depending upon slip of load torque, motor operate at a certain speed n. And to reduce speed, when we reduce frequency from F1, F2, F3 to F4, it reduce synchronous speed, and for same amount of operating slip, the operating speed of motor get reduced. But during this operation, we also reduce stator applied voltage in the same proportion as applied frequency and maintain constant V to F ratio, and that maintain constant air gap flux and rotor maximum current capability produce torque capability of motor. So during this reduced frequency operation to get reduced speed, when voltage and frequency simultaneously reduced in the same proportion, the maximum torque capability of induction motor remains the same, and this operation of speed reduction by reduced speed with constant V/F ratio is known as constant torque control of induction motor. Whereas to increase speed, we increase synchronous speed by increasing frequency, and we maintain constant stator applied voltage, and with constant voltage and increased frequency, air gap flux get reduced, and that field flux reduction reduce maximum torque capability of induction motor. And when increased speed shift torque speed characteristic to a higher synchronous speed, our operating point can shift to a new high speed torque characteristic only when it is a constant power type of load, where load torque requirement for increased speed get reduced, and we get considerable control of increased speed by increasing frequency at constant voltage, and this control is known as constant power region control. So for speed reduction, when frequency is reduced, the terminal voltage of stator also get reduced and V/F ratio is maintained constant, and this control is known as constant torque region control. Whereas for increased frequency operation, we maintain constant voltage and motor maintain constant power characteristic, and a load having constant power characteristic can have an increased speed operation by increasing frequency of supply. For controlled variable speed operation of three-phase induction motor, we need a variable frequency supply, and that variable frequency supply use fixed voltage fixed frequency means AC supply, and convert that into variable voltage and variable frequency alternating current supply suitable for motor operation. Now this variable frequency drive is not only most important and powerful component of our application, it is also the most costliest part of our drive system. Modern VFD not only control operating speed of induction motor, they can also control load torques, the direction of motor, and they have also inherent inbuilt capability of soft starting and soft stop if required, and that soft starting and stop can reduce starting inrush of current and sudden jerks on starting and stop conditions, and that reduce electrical as well as mechanical shock and jerks to motor driven system. Now modern VFD most commonly used voltage source type of inverter circuits, and in voltage source inverter circuits we have mainly 4 sections, and 3 sections as shown here are used. As the first section is known as rectifier section, which convert mains AC supply of fixed voltage fixed frequency into a DC voltage, and the ripple of DC are filtered by series inductor and shunt capacitor, and these filter also store DC power for further inverter operation, and this DC link gives a DC output to an inverter circuit which is IGBT based switching circuit, and that convert DC output of DC link into variable voltage and variable frequency AC supply for motor. For mutual coordination among these sections and to maintain desired output, the feedback of input supply and load parameter are taken in consideration, and a microprocessor based controller control switching operation of IGBTs to maintain desired output. So the 4 sections of modern VFD are rectifier, DC link, inverter, and a microcontroller. Let's understand all these sections in good detail. A variable frequency drive shown here provide variable voltage, variable frequency, 3-phase alternating current output for controlled variable speed operation of 3-phase coil cage induction motor, and it use a fixed voltage fixed frequency mains 3-phase AC input, and the first stage convert this AC into DC, and this rectifier is basically a bridge circuit. And in DC link, series inductor and shunt capacitor not only filter ripples in rectified output, also store reactive energy for smooth operation of inverter circuit, and they have also a regulator which regulate DC output voltage for inverter. And IGBT switching devices produce desired variable voltage and variable frequency AC output depending upon switching control by microprocessor based based control unit, and this control unit use control signal for speed reference as well as feedback of input AC supply and output mechanical load parameter. Let's understand these four sections: rectifier, DC link, inverter and controller, one by one in detail. The first stage of variable frequency drive is a rectifier, and we use a three-phase full-wave bridge rectifier consist of 6 diodes as shown here to convert three-phase means AC into rectified DC at output. And in this bridge rectifier, when three-phase AC supply is given, the maximum line-to-line voltage which exists between any two lines forward bias 2 diode, and we got 6 pulses of maximum line voltage output as one directional DC output from this full wave bridge type rectifier. So this uncontrolled diode three-phase full wave bridge rectifier produce a constant DC magnitude with certain amount of ripples as its output. Now we can control DC output of a rectifier even when we have fixed three-phase AC voltage applied at input. But for that, in place of simple diode switch, we have to use SCR as switching device, and this three-phase full wave fully controlled SCR bridge rectifier circuit can produce a variable DC output here. Now these full controlled rectifier circuit are basically bidirectional switching circuits, and they can convert the DC applied here into a three-phase AC because these thyristor switch can work in both directions. So when we have to use regenerative braking facilities in induction motors, we use such full controlled SCR type bridge rectifier. But in general applications, we will use simple uncontrolled diode rectifier, which are not only economic in design, they are also convenient to operate and have more reliability and better performance. The output of a rectifier is fluctuating DC, and that contain fluctuation in terms of ripples, and even its magnitude is not constant. And for an inverter operation, we need a smooth and stable DC output. So this fluctuating DC is converted into smooth and stable DC by a DC link, and this DC link perform two functions. It filter the ripples and regulate the voltage magnitude. For filtering action, we use large size series inductor which filter out current ripples in our supply, and we also use good size shunt capacitor which remove voltage ripples in rectified output, and then we use regulator which stabilize the output voltage. So this DC link filter, store and deliver DC power to inverter, and will get smooth stable DC output from DC link for inverter. Inverter is the most important part of variable frequency drive, and it receives smooth regulated DC output from DC link and convert that into a variable voltage and variable frequency three-phase AC output supply, which is used to control speed of three-phase induction motor. Modern voltage source inverter circuit consists of integrated gate bipolar transistor or IGBT switches, and these IGBT switches are controlled by a microcontroller unit, and modern inverter use PWM pulse width modulation technique to get almost a pure sinusoidal output with minimum amount of harmonics so as to improve motor performance at all voltage and frequency conditions. And this microcontroller control switching of these IGBT switches in such a way that will get desired voltage and desired frequency output for this three-phase motor. In inverter operation, switching of power electronic IGBT switches is controlled by a microcontroller unit, and this unit produce switch DC voltage output at high frequency, and a series of short wave pulses are synthesized in such a manner that they will produce a desired voltage and desired frequency alternating voltage output. This microcontroller unit control on and off duration of these pulses and control positive sequence and negative sequence pulsed output in such a way that resultant pulse width modulation manage a nearly sinusoidal output wave, and we get a good fundamental frequency component and reduced harmonic component by this PWM technology. In pulse width modulation PWM technology, we use pulses of constant magnitude but controlled duration in such a way that for low voltage output at low frequency, short pulses are used and a longer duration is taken for positive half cycle, and then then similar negative half section is created, and for higher voltage magnitude and higher frequency, wider pulses are used, and in smaller duration the positive pulses are changed to negative pulse rate in such a way that resultant voltage magnitude synthesize a nearly sinusoidal output voltage of desired voltage magnitude and desired frequency over time. So we can change magnitude of output voltage by the width of pulses, and the frequency is adjusted by changing time period of each half cycle as shown in these waves. The switching of IGBT switches is controlled in such a manner that for middle pulses the width is taken relatively larger, and for side pulses short width pulses are used, and they together when synthesized form a almost sinusoidal current distribution for output supply. And a microcontroller control switching of IGBT switch by PWM technology in such a way that will get desired output frequency and voltage magnitude. The high speed switching action of PWM inverter results in less waveform distortion and decrease harmonic component, and that improve motor performance and reduce harmonic losses in motor operation. Modern variable frequency drives have greater functional capabilities and operational facilities. They not only provide desired variable voltage and variable frequency output for three-phase induction motor, they can also used for soft starting or regenerative braking, and the entire operation of variable frequency drive is monitored by a microcontroller or a microprocessor, and this microprocessor control unit control switching operation of IGBT switches and also take care of feedback from motor load parameter and supply voltage parameter. The main job of microcontroller unit in VFD is to check output voltage and output frequency as well as current in line, such as to ensure operation of motor within desired speed and established parameters. But apart from that, controlling operation of three-phase induction motor, our microcontroller also monitor parameter of incoming supply voltage and accordingly adjust switching duty cycle of IGBT to get desired output. It also have to set the desired operating speed of motor, and accordingly microcontroller control switching of IGBT switches. It also take feedback signal to monitor DC link voltage state. It can also monitor fault conditions in anywhere in variable frequency drive or motor operation and accordingly protect motor and allied circuitry. And it also have facility to interface communication protocol and can send vital process parameter to a remote position using communication systems. Modern variable frequency drives use latest control techniques and microcontroller that allow accurate closed loop controlling of motor operation, and every time we compare the real operating speed of motor and reference speed, and even when there is a changes in mechanical loading of motor or there is a change in input supply parameter, even in voltage fluctuations, the VFD microcontroller manage switching action in such a way that desired operation of motor at required speed condition is managed. The microcontroller unit combine the duty cycle function and control switching of IGBT switches with current reversing function so as to manage frequency of output supply, and in this way we can manage both voltage magnitude and frequency as per our speed requirement. Modern variable frequency drives also have a capability to regulate ramp up of voltage for soft start, and they can also provide ramp down of supply voltage for soft stop of motors if required. And some VFDs also have regenerative braking facility, and during stop action they can regenerate inertial energy back to supply side. In recent past, tremendous improvement has taken place in power electronic switching devices and microcontroller, and modern solid state electronic used in variable frequency drives are more reliable and almost maintenance free. Now most VFD devices have built-in diagnostic system as well as protective relay and fuse systems to provide inherent protection against all adverse fault conditions. The electronic component of VFDs are usually mounted into to an electric enclosure that ensure adequate protection from all environmental conditions such as contamination or ingress of dirt, dust, water, and there exist ventilating ducting provisions in the enclosure that provide required heat dissipation, ventilation and cooling to our power electronic devices. There are several advantages and benefit of use of variable frequency drives in fan, pump application or in heating, ventilation, air conditioning unit or other motoring systems. The installation and maintenance of VFD is quite simple, and 3 line wire connection and 3 motor connection is good enough to connect VFD with supply and motor. Modern VFD have facility of not only speed control as required in motor operation, they can also provide soft starting and soft stop operation as required. The dynamic response and transient operation of VFD is also very good. So in case of fluctuation in supply voltage or in mechanical loading conditions, VFD can adjust its operation and maintain stability in operation. When we use VFD, we change applied frequency and synchronous speed, so torque speed characteristic of motor get changed, and every time for desired torque condition the motor operate at small value of slip at all speeds, and that results in smaller value of copper losses and higher efficiency and better power factor. Now the soft starting by VFD ensure effective reduction in rush of current and jerk of mechanical starting torques, and this reduce all sort of electrical, mechanical and thermal stresses on motor winding and connected power transmission systems. So it not only reduce maintenance problem, it also enhance working life of motor and driven system. Apart from significant benefits, there exists certain disadvantage of voltage source inverter based variable frequency drives. These variable frequency drives have a very poor lagging power factor, especially when we operate motor at a low speed and produce low voltage and low frequency output. When our supply frequency is reduced to a very small value, say below 6 Hz frequency, then output have considerable amount of harmonics and they cause motor to cog. So due to cogging, motor may refuse to start when supply voltage and frequency both is reduced to a very small value. As majority of voltage source inverter use a plain uncontrolled diode rectifier set, so we cannot adopt this variable frequency drive for regenerative short of breaking. For successful operation of variable frequency drive in the application of variable speed of induction motors, following technical point must be considered, and they are very important. The key points are: the ability of motor to cool itself effectively also get reduced. So in such slow down conditions of motor, we have to use external forced air ventilation so as to dissipate heat produced by internal losses, especially at motor operation of very low speed with high amount of load torque when motor is drawing high current and running at low speeds. When a motor is operated on continuous varying frequency, the mechanical attached part of driven system may cause some sort of mechanical resonance at some specified reduced speed conditions, and these speeds which produce resonance and cause excessive vibration and noise in mechanical driven equipment should be identified, and during our reduced speed operations with varying frequencies, we should avoid operation of motor for those frequencies, and identified frequencies must be programmed out by controller so that motor should not get such troublesome condition of mechanical resonance in driven components. Electronic power circuits of variable frequency drives are inherently non-linear, and they generate harmonic voltages and current signals in its output, and these harmonic signal can propagate through entire power system and cause undesirable effects on electrical distribution system and even affect the motor operation, for which VFD is used to control speed. Some odd harmonics may produce reverse rotating torque conditions, and during operation we have to avoid overcome this counter rotating torques created by odd harmonics. And from a practical point of view, during VFD application, the total harmonic distortion of current at the terminal of driven motor at rated load condition should not be more than 5%. They should be limited as less than 5%. Sometimes, to reduce ill effects of harmonic components in power system, we must use isolation transformers or suitable line reactor or filter component to minimize ill effect of harmonics. If a longer length cable is used to connect VFD and motor terminals, especially when motors are mounted on certain height position on process equipments, then longer length of cable create voltage transients and that may damage insulation of connected motor. So we should limit length of cable connections from VFD to motor less than 15 meters wherever it is possible, as voltage transient may get produced by VFD connections. So insulation of few turns of motor winding are also strengthened, and overall winding insulation of that motor which is designed to operate on VFD supplies must be improved, and this need additional lacing on end turns by phase paper or VIP resins or pulse resistance magnet wire enamel, and this enamel normally which is double on motor winding turns must be either tripled or quad made 4 times in layer to strengthen and improve insulation quality of winding so as to withstand high voltages stresses which may get developed by a ringing effect on VFD and motor connection. We hope now you understand all 4 block of variable frequency drive working, and now you understand what's the role of rectifier, DC bus, inverter and control unit, and you also understood what precautions technically required to use variable frequency drive. If you found this learning video useful, do share it with your friends. You may also like our other video of the same playlist, and our power electronics and power system playlist is also very useful. We hope you will definitely appreciate that learning work. Happy learning. Thank you very much.